Modern physics, it's incredible. It's one of the greatest things humanity has ever come up with. It's given us GPS, medical imaging, pretty much everything in our modern world. But today, we're not here to just sing its praises. Instead, we're going to do a little investigating. Guided by our source material, we're going to explore some really deep, tough questions. Questions that suggest there might be a pretty fundamental problem at the very heart of how we see the universe.
All right, let's just dive right in, no messing around. The source we're looking at today asks a huge question. Is the very foundation of modern physics, well, is it flawed? That is a bold, bold claim, so let's see what kind of evidence it brings to the table.
I want you to imagine physics as this magnificent, gleaming skyscraper. It's just massive, it's impressive, it works, and it looks totally solid. But our job today is to take the elevator down to the basement, get out our flashlights, and start tapping on the walls, looking for cracks in the concrete, the very assumptions that the entire structure is built on.
So, the source makes its case through 5 core challenges, and the argument is that these aren't just little, minor puzzles that we'll solve eventually. Nope, it claims these are deep, foundational questions that all point to a single, much bigger problem. So let's go through the evidence, one piece at a time. Okay, this first challenge, it's a real shocker. Because it doesn't question some complex theory about black holes or quantum mechanics, it questions the very language that physics is written in, mathematics. The question is, are the very tools we're using to build our theories fundamentally unsound?
Now, what's so fascinating here is just how direct this is. The source is basically claiming that these core ideas we totally take for granted, like infinity or the concept of continuity, the idea that space and time are perfectly smooth and unbroken. It says the definitions are, and I quote, not correct and misleading. That's a huge accusation to make against math itself.
So why is this such a big deal? Well, that idea of continuity, that everything is smooth, is the absolute bedrock for Einstein's general relativity. If that definition is flawed, like the source is claiming, then our entire theory of gravity could be built on shaky ground. It's exactly like finding out the concrete in that skyscraper of ours is weak. All of a sudden, the entire structure is at risk.
So let's move on to the second challenge and see how this argument builds. This one gets a little more philosophical. It asks a pretty profound question. Are all our powerful mathematical equations actually explaining the universe, or are they just describing it? So the source argues that physics is missing something absolutely essential. We have the math, sure, and we have the symmetries, but we don't have what it calls the complete machinery. So what on earth is that supposed to mean?
Well, the machinery is the how. It's the why. It's the actual engine under the hood that makes all the rules work. Think about it like this. Newton's law of gravity can tell you that an apple will fall, and it can predict its path perfectly. But the machinery would be the actual physical mechanism that explains why gravity is pulling things together in the first place.
And this right here is the core of the argument. Math is absolutely amazing at describing what happens. It can predict where a particle is going to be with mind-blowing accuracy. But the source is claiming we're missing the deep explanation for how and why it takes that path. It's like we have the user manual for the universe, but we've never actually seen the engine.
Okay, so let's make this less abstract. Challenge number 3 takes this whole idea of missing machinery and applies it to the very particles that make up you, me, and literally everything you can touch. We're talking about fermions.
I mean, that's a direct shot. Fermions are the building blocks of matter, electrons, protons, neutrons. We have rules that describe how they act, but the source asks a pretty pointed question. Why aren't we even looking for the physical mechanism that forces them to follow those rules?
So here's the crucial part. We have these incredible rules, like the Pauli exclusion principle, which basically says 2 fermions can't sit in the exact same spot. It's a fundamental rule of our universe. It works, but according to this argument, we have absolutely no idea why. It's like we have a law, but we don't know who or what is actually enforcing it.
All right, our fourth challenge takes us away from the building blocks of matter and over to the particles of light. And this one leads us into a genuine paradox right at the heart of Einstein's relativity.
This is one of those questions that sounds pretty simple at first, but honestly, it just gets weirder and weirder the more you think about it. A photon goes through changes, right? It's created in a star, it travels for billions of years, and then it hits your eye. That's a journey. But from the photon's point of view, no time has passed. At all. How is that even possible?
Now, this isn't just some fun little brain teaser. It's a really deep puzzle. I mean, if something experiences a sequence of events,
Birth, travel, death. That sounds an awful lot like the definition of time passing. But our best theory of spacetime says that for that photon, it all happened in a single timeless instant. It really suggests our understanding of time might be seriously incomplete.
And that brings us to the big one, the fifth and final challenge. And it's one of the most famous, most glaring mysteries in all of science, the problem of dark energy.
The source really doesn't pull any punches here. It basically says that our best explanations for whatever is causing the universe to expand faster and faster are just unlikely scenarios. I mean, we can see it happening, the universe is flying apart, but we have no credible idea what's actually stepping on the gas pedal.
And look, this is a huge deal. Dark energy makes up almost 70% of the stuff in the universe. It's the dominant force in the entire cosmos, and we are fundamentally clueless about what it is. The source calls this out as a massive red flag that our current models are missing something gigantic.
So we've looked at 5 major challenges. We've got flawed tools, missing explanations, and 3 huge unsolved mysteries. And the source's main argument is that these are not 5 separate problems. They're all just symptoms of the same underlying condition.
So here's how the source connects them all. It's like a chain reaction, a domino effect of doubt. You start with flawed mathematical tools. And because your tools are flawed, you can only ever describe what you see. You can't find the real machinery underneath. And because you can't find the machinery, you end up with these massive, unsolvable mysteries. It's all one connected story.
But you know, the point of all this criticism isn't just to tear everything down. The source argues that when a scientific framework has problems that are this deep, this fundamental, it's a signal. It's a sign that we need a new one. And it proposes a path forward. So, what is this new path? Well, the source puts forward something it calls a 2-level model of reality. The big idea is that there's a deeper, more fundamental level of reality underneath the one we see and measure. So, while current physics is great at describing what happens on the surface using ideas like continuity, this new perspective wants to uncover the hidden machinery that's running the show at that deeper level. It's a whole new framework, one that the source argues could be the key to finally explaining why things work the way they do.
And that's where we're left. The source material we've gone through today makes a powerful case that our inability to answer these 5 questions is a pretty clear sign that something is wrong. It's an invitation to be bold. It suggests that real progress sometimes requires the courage to question our most basic fundamental assumptions. And really, at the end of the day, isn't that what the adventure of science is all about?